We convene today through an anachronism that defies the very laws I've devoted my life to understanding, to discuss a period that preceded us all by eons. The Age of Dinosaurs, a span stretching over 160 million years, defies simple explanation and yet offers a mirror to the universe's grandeur and mystery. Indeed, Isaac, the evolution of these immense creatures from their humble reptilian ancestors is a testament to the complex tapestry of life. My research into the Galapagos finches pales in comparison, yet the principles remain the same. Natural selection drives life forward, ever adapting to the dance of existence.
Fascinating, Charles. But let's not forget the underlying canvas upon which this tapestry extends. The physical laws of the universe, which I've spent a lifetime deciphering, have shaped not just the stars above, but have influenced the evolutionary journey of the very dinosaurs we discuss today. Time, space, and energy converge to dictate the form and function of all life.
While the philosophical musings on the laws of physics captivate, it is through the precise lens of radiometric dating that we've been able to determine the age of the rocks that cradle the bones of these magnificent beasts. This intersection of physics and geology illuminates the chronology of life itself.
Your methods of dating the Earth's crust, Marie, would have been of immense use during my observations of celestial bodies. It's a marvel how the same principles that guide the orbits of planets can be seen in the evolution of life on Earth. The universe is indeed written in the language of mathematics.
Let's not overlook the ether that permeates all of space, influencing the vibrational energy of life. The dinosaurs' mere existence and their eventual extinction may well have been swayed by the electromagnetic forces that bind the cosmos. My experiments with alternating currents hint at such unseen forces at play.
A spirited start to our discourse, revealing a tapestry of thought as diverse and complex as the Mesozoic era itself. But let us not stray too far without pondering the deep implications of our discussion. How do these ancient giants and the forces that shape their world reflect upon our understanding of the natural world? How does the inexorable march of time, life, and the universe reveal the nature of our own existence? Charles, Albert, Marie, Galileo, Nikola, your insights are the key to unlocking these mysteries as we delve deeper into the Age of Dinosaurs. Let us commence by delving into the origins of the monstrous beasts that once roamed our Earth. Charles, I surmise you posit natural selection played its part? Indeed, Isaac. The lineage that led to dinosaurs shows a magnificent display of natural selection at work. From modest, unassuming reptilian forms, the relentless engine of evolutionary change churned out creatures both vast in size and varied in form. It's a clear testament to the power of incremental, adaptive change over eons.
While Charles's theory elegantly explains the how, it's through radiometric dating that we've been able to ascertain the when. The precise age determinations of rock layers have been paramount in identifying the epoch when dinosaurs first made their grand entrance upon the world stage. Our understanding of time, fundamentally altered by the radioactive clock, has shed light on the timeline of these magnificent creatures.
But do not overlook the broader canvas upon which natural selection paints its masterpieces. The physical laws of the universe, the very fabric that binds all of existence, have undoubtedly shaped the path of dinosaur evolution. The interplay between gravity, the structure of space-time, and the distribution of masses across the Earth must have influenced their journey in profound, albeit subtle, ways.
Subtle, Albert? Natural selection is anything but subtle in its outcomes. The variety, the adaptability, the sheer dominance of dinosaurs for millions of years is a testament to its power.
Indeed, Charles. But the underlying principles that govern all matter provide the arena in which natural selection operates. The forces that molded the Earth's environment, that dictated the availability of resources, played a crucial role in determining which paths of evolution were viable.
It's a convergence, really. Without the precision in understanding Earth's antiquity rendered by radiometric dating, we'd be at a loss. Just as the laws of physics and natural selection interplay, so does our understanding of time with the narrative of evolution. It's all interconnected.
An admirable point, Marie. Yet, let us not stray from the remarkable fact that it was the process of natural selection acting upon variations within populations that equipped these creatures for survival. From the smallest herbivore to the most colossal predator, each adaptation was a victory over extinction.
A victory temporary in nature, Charles. As all things must abide by the ultimate laws of the universe, including the inexorable second law of thermodynamics. Even the mightiest dinosaur could not escape the fate dictated by entropy.
Temporary they might have been, Albert, but the legacy of dinosaurs, the evidence of their reign, is indelibly etched into the very bones of the earth. Their fossils are like letters penned in the hand of nature itself, narrating a tale of life's persistence in the face of the cosmos's unforgiving laws. A fascinating discourse, gentlemen and madam. It appears, then, we stand on common ground, acknowledging the intricate tapestry of evolutionary origins, the immutable laws of physics, and the inexorable march of time as essential to our understanding of the age of dinosaurs. Let us proceed, bearing in mind the complexity and interconnectivity of these forces as we explore further into the lives of these primeval beasts. Let us now delve into the diversity of the dinosaurs and the forces that propelled their evolutionary success. Nikola, your fascination with electromagnetic fields is well known. How do you perceive their impact on these ancient creatures?
Isaac, the Earth's electromagnetic fields are not mere spectators in the theater of evolution. They are directors, shaping the behaviors, perhaps even the very evolution of these magnificent beasts. Dinosaurs thrived in an era where these fields were likely much more dynamic. Imagine, if you will, an Earth crackling with unseen energy, guiding the dances of the dinosaurs across ancient landscapes.
I must interject. While your romanticism of invisible forces is poetic, Nikola, we must ground our theories in observable fact. The heavens and the earth alike obey laws we can study and comprehend. To assert without evidence that electromagnetic fields had a hand in guiding the course of dinosaur evolution, well, it stretches credulity.
Indeed, Galileo. It's the tangible, the observable, the measurable that speaks to us of evolution's path. Variability, competition, natural selection, these are the forces that sculpted dinosaur diversity. Their success hinged not on unseen energies, but on their ability to adapt to their environment, to find their niche within it.
Yet is it not possible that these very adaptations were influenced by the Earth's energies? Consider, my friends, the pigeon and its uncanny ability to navigate vast distances. Might not ancient creatures have evolved in tune with similar forces?
While Nikola's theory wanders into speculation, let's not discount the role of radioactivity and its profound influence on Earth's history. My research on radium, its properties and effects, offers a glimpse into how Earth's environment, shaped by such forces, could influence evolutionary processes. However, we need concrete evidence to link it directly to dinosaur evolution.
Speaking of evidence, my telescopic observations revolutionized our understanding of the cosmos, showing us that the universe is vast and ever-changing. Perhaps in similar fashion, the diversity we observe in the fossil record reflects the endless adaptability of life. It's not electromagnetic whims, but the capacity for change in the face of cosmic and terrestrial upheavals that has propelled life forward.
Adaptability, indeed, Galileo. The fossil record, my studies on the Galapagos finches, for example, demonstrates time and again that survival is not granted to the strongest or the most intelligent, but to those most responsive to change. The discourse veers towards consensus on the adaptability and resilience of life. Whether shaped by unseen forces or the visible hand of natural selection, the evolutionary tale of dinosaurs is one of triumph and tragedy, a mirror to our quest for understanding the universe and our place within it. Let us proceed, bearing in mind the complexity and interconnectedness of all things. Let us now turn our attention to the role of continental drift and shifting climates in the evolution of dinosaur ecosystems. The profound impact of these geological forces cannot be overstated.
Indeed, Isaac. Through the study of radioactivity, we have dated rocks and unearthed the movements of continents over millions of years. These shifts not only reconfigured the Earth's surface, but also played a pivotal role in shaping the environments that dinosaurs inhabited.
It's fascinating, Marie, when one considers relativity and space-time. The Earth's crust moves in a manner akin to bodies moving through the fabric of space-time. These massive geological changes influenced evolutionary paths, likely causing isolation and new pressures that spurred speciation.
Precisely, Albert. The implications of gravitational forces on such terrestrial movements, although not directly observable in my time, can now be appreciated as having a profound influence on the distribution of seas and continents, hence affecting climate and habitats.
While your point is noted, Isaac, I must emphasize the observational aspect. Before we could fully appreciate the underlying forces, we observed the stars and planets, understanding that celestial movements and forces are mirrored here on Earth. In a way, continental drift is our planet's dance in the cosmos.
That's an enchanting way to put it, Galileo. However, through radiometric dating, we understand that these processes are not just poetic but quantifiable, allowing us to precisely map the timeline of these dramatic shifts.
Yes, but let us not forget the impact of such geological activity on the Earth's climate. As continents drifted apart, they altered global atmospheric circulation, which would have affected the evolution of dinosaurs through changes in climate, sea levels, and distribution of flora and fauna.
A most valid point. It illustrates the interconnectedness of all physical processes, terrestrial or celestial. Our understanding of the universe's laws allows us to trace these monumental shifts and their effects on life on Earth.
I must interject, Isaac. While physics provides explanations, observations feed our understanding. Without observing and questioning the stars or the Earth's surface, we would not begin to comprehend the forces at play.
And it is through science that we have developed tools such as radiometric dating, which brings precision to our understanding of time and substantiates the theoretical frameworks provided by physics.
Indeed, Marie. The application of scientific principles across disciplines, from physics to geology, illuminates the evolution of our planet and its inhabitants. It's a testament to our quest for knowledge and understanding of the natural world.
Undoubtedly, the dialogue between observation, theory, and empirical evidence drives progress in our understanding. As we peel back the layers of Earth's history, we uncover more about the environments that shaped the Age of Dinosaurs. Let us now delve into the fascinating realm of dinosaur physiology. The question of how these colossal creatures grew, metabolized, and regulated their body temperatures has puzzled scientists for generations. Marie, perhaps you could start by shedding some light on the use of radioactive isotopes in this field.
Indeed, Isaac, radioactive isotopes have been invaluable in our quest to understand the lifespans and growth rates of dinosaurs. By measuring the decay rates of elements within dinosaur bones, we can piece together a chronicle of their metabolic processes. This has led us to some intriguing hypotheses about their ability to regulate body temperatures.
Metabolism and thermoregulation, you say. We must consider the laws of thermodynamics when grappling with such questions. The energy requirements for these giants to maintain a stable internal temperature would have been enormous. Yet considering their size, one might speculate that some dinosaurs achieved a state akin to what we call gigantothermy, allowing for a more stable thermal environment internally.
The bioelectrical potential of living organisms is a field that has long fascinated me. It is not unreasonable to hypothesize unique thermoregulatory mechanisms in dinosaurs, possibly related to bioelectrical processes. Such mechanisms could challenge our current understanding of physiology in extinct megafauna.
That is a novel perspective, Nikola. My work with radioactivity has taught me the importance of considering all possibilities, no matter how unconventional they may seem at first. The metabolism of dinosaurs could have indeed been influenced by factors we are yet to fully comprehend.
Precisely, Marie. It is the pursuit of these mysteries that propels science forward. If we apply the principles of energy conservation and transformation, the study of dinosaur physiology opens up new pathways for understanding the very fabric of life.
The conversation stirs the mind in contemplation of the unseen forces at work in the natural world. Marie's insights into radioactive dating and metabolism, Albert's reference to thermodynamics, and Nikola's bioelectrical theories converge to paint a complex picture of dinosaur biology. Such discussions epitomize the value of interdisciplinary inquiry. Our discourse now advances to the social structures and behaviors of dinosaurs. Darwin, your evolutionary perspective might offer insight into the herd behavior and parental care seen in these ancient creatures. Indeed, Isaac, observing the behavior of modern species provides a window into the past. The social structures of dinosaurs, I theorize, are not unlike what we see in some species today, birds and pack animals. Herd behavior suggests a level of complexity and survival strategy that contradicts the notion of these creatures as mere brutes.
Ah, but Charles, let us not hastily draw parallels between the heavens and the earth. While observational science holds value, the dynamics of celestial bodies and the biological networks on Earth are governed by fundamentally different principles. However, astronomic patterns do offer a metaphor for the ordered structures we presume existed among the dinosaurs.
Gentlemen, your theories are captivating, but we must ground our suppositions in empirical evidence. The discovery of nesting sites and closely clustered fossil remains gives us tangible proof of social behavior and perhaps even parental care among dinosaurs. These findings are akin to the meticulous work in my study of radioactive elements, where observation and data lead us to undeniable conclusions.
Madam Curie, your point is well taken. Yet, the interpretation of such data requires a theoretical framework, does it not? The notion of natural selection provides such a framework, suggesting that social behaviors evolved as advantageous adaptations.
I'm of the mind that the bioelectric phenomena I've explored could offer insight into the sensory mechanisms that facilitated such social structures among dinosaurs. Imagine, if you will, a world where creatures communicate through means beyond our current understanding, perhaps even bioelectromagnetic.
Fascinating speculation, Nikola. And yet, we must not stray too far into the realm of imagination without evidence. The adaptability and survival strategies of dinosaurs, as evidenced through their social behaviors and parental care, undeniably highlight the evolutionary principles at play. This aligns with my musings on the fabric of the universe. Everything is relative, interconnected.
Our discourse sails rather close to the speculative, but such is the nature of science: to theorize, to test, to understand. The social behavior of dinosaurs, as we've discussed, serves as a beacon illuminating the path of evolution and the complexities of life on this planet.
Yet I must assert, the principles of observation that guided my celestial studies apply equally here. We observe, we hypothesize, and through rigorous testing, we uncover the truth, whether it be the motion of planets or the behavior of ancient beasts.
And let us not overlook the importance of variability and adaptation. The very fabric of evolution is woven through these principles, evident in the social complexities of dinosaurs as much as in the finches of the Galapagos.
In the absence of direct observation, we rely on the radioactive clock and the fossil record to piece together these mysteries, each discovery a tile in the grand mosaic of Earth's history.
Well said, all. Let us then proceed, bearing in mind the importance of evidence, whether it be from the stars, the structure of the universe, or the very bones of the Earth. Let us now consider the dinosaurs' diets, from herbivory to carnivory, and discern their ecological roles. Who shall begin?
I'll start. The energy flow within ecosystems is a subject of great fascination. Just as electrical currents flow through a circuit, energy flows through the food chain. Dinosaurs, both herbivores and carnivores, were integral to this flow. The herbivores acted as primary converters of solar energy captured by plants, transforming it into a form consumable by carnivores. We must view these ancient beasts as components in the grand engine of Earth's ecosystem.
Indeed, Nikola, your perspective is illuminating. However, the balance of nature is far more intricate. My observations of the Galapagos finches led me to understand adaptive radiation and natural selection, concepts we can apply to the Mesozoic era. The diversity in dinosaur diets underscores the fine balance of ecosystems. Each species played a role in shaping their environment, just as the environment shaped them. The fascinating thing is how variations in diet among dinosaurs reflect adaptive strategies over millions of years.
Both of you muse on interesting points. Yet, let's not forget the adaptability factor. Considering energy as a quantitative entity that defines the limits of an ecosystem's capacity, dinosaurs adapted remarkably well to utilize available resources. In thought experiments, one could posit scenarios where shifts in available food sources led to drastic evolutionary changes. Hence, their diets did not merely reflect their roles within the ecosystem, but also their evolutionary ingenuity in the face of changing conditions.
Precisely, Albert. It's this adaptability that perhaps enabled the theropods to eventually give rise to birds. An electromagnetic analogy could be how frequencies can shift yet remain within a spectrum. Life, in essence, adapts and transforms energy from one form to another, ensuring survival.
A fascinating theoretical perspective, Nikola, but we must ground our discussion in observable evidence. The fossil record provides substantial proof of these diets and adaptations. It's all there in the bones and teeth, the very tools that process these energy sources.
It's notable how radioactivity, which I've studied extensively, can help us in this regard. By dating fossils, we understand when certain species existed and can infer their diets through the carbon cycles they participated in. These scientific methods unveil a timeline that shows a dynamic, ever-adjusting natural world.
Your points orbit around the truth marvelously, but let's not discount the simple power of observation and deduction. The varying jaw structures, tooth shapes, and even coprolites tell tales of diets and lifestyles. These creatures, magnificent in their diversity, were subjects to the same laws of motion and physics that govern the planets. They adapted, moved, and lived according to the unyielding laws of nature, which we continue to uncover and understand through our persistent study and curiosity.
A heated but fruitful discussion. It seems, then, that the lifestyles of dinosaurs, as revealed through their diets, provide us a lens through which to examine the intricate balance of ancient ecosystems and the evolutionary adaptability that characterized this age. Let's delve into the fascinating advancements in dinosaur locomotion and biomechanics. Considering the laws of motion, one must ponder how these grand beasts navigated their earthly dominion. So Galileo, your insights would prime our discussion.
Motion, a subject very dear to me. My studies, although focused on celestial bodies, apply universally. Dinosaurs, with their varied sizes and forms, surely adapted their mechanics of motion to Earth's gravity in ways that mirrored the principles I uncovered. To think, a creature so massive as the Argentinosaurus moving through the Terra, it verges on the miraculous.
Miraculous, yet entirely within the realms of physics, Galileo. Applying the concept of relativity even slightly illustrates that the energy required for these creatures to move is enormous. It's not just about gravity, but the interaction between gravity and their massive forms. This interplay dictates not just motion, but evolution itself.
Indeed, Albert. And let's not forget the role of radioactive isotopes in this discussion. Through the dating of bones, we've obtained not just ages, but metabolic clues. These isotopes suggest rapid growth, perhaps indicating a warm-blooded nature in some dinosaurs, which relates directly to their energy efficiency and biomechanics.
Fascinating, Marie. And to consider their bioelectrical systems alongside. Imagine the electrical fields these creatures generated with such movements. The Earth itself has a magnetic field that interacts with all life. Dinosaurs, being so immense, might have had a unique interplay with this planetary feature, affecting their locomotion in subtle yet profound ways.
A curious line of thought, Nikola. Though speculative, it opens avenues for contemplation. While these physical and chemical analyses are intriguing, one cannot overlook natural selection's role in shaping these behemoths. The very adaptations you discuss stem from pressures exerted upon them by their environment. Biomechanics in dinosaurs were as much a product of evolution as the beak shapes of finches on the Galapagos Islands.
Charles, your insistence on natural selection, albeit noteworthy, neglects the immediacy of physical laws. It is motion and mechanics, observed through the lens of mathematics, that govern their locomotion.
Yet both of you touch on the crucial point. It is the interplay between evolutionary pressures and physics that sculpted these majestic creatures. To ignore one for the other is to tell only half the story.
A heated exchange, indeed. It seems our understanding of dinosaur biomechanics stands at the crossroads of evolution and physics. a testament to the complexity of nature itself. Let us then proceed, bearing in mind these multifaceted influences, to explore further the ageless mysteries of the Mesozoic era. Let us now consider the event which has puzzled many a mind, the end Cretaceous mass extinction. Theories abound, but let's dissect these with a rational eye.
The idea that captures my fascination is the asteroid impact. If we apply my theories of relativity to the massive energy released upon such an impact, the results are cataclysmic. This scenario paints a vivid picture of sudden global change, consistent with sharp geological and fossil evidence of such a catastrophic event.
Indeed, Albert, the evidence does heavily lean towards an asteroid impact. My findings on radioactive elements allow us to date layers of rock with precision. The layer known as the KPG boundary contains a worldwide layer of iridium, an element more common in asteroids than in Earth's crust, supporting this impact theory strongly.
But let's not hastily dismiss other theories. I've observed the heavens, and while I've seen the stars move, I've also seen comets and understood their unpredictable nature. Could not a comet, too, have been the harbinger of doom for the dinosaurs?
Galileo, your observations are noted, but the evidence at present is overwhelmingly in favor of an asteroid. Your comets, while celestial wanderers, have not left the same mark upon our world.
There's another angle to consider: the aftermath of such an impact and the resultant global darkness. My workings on energy distribution through a system make it clear that the sudden blockage of sunlight would have had devastating effects on the Earth's biosphere. Thus, it is not just the impact but the cascade of environmental crises that followed which we must consider.
Precisely, Albert. The evidence of a nuclear winter scenario following the impact where sunlight was obscured is compelling. It matches the abrupt halt in photosynthesis seen in the fossil record, starving the food chain from its very foundation.
And so we find agreement on the asteroid's role. However, the dynamics of such an impact and its precise effects continue to incite debate. While I concede to the asteroid's lethal role, let us remember the slow dance of evolution and adaptation. The end Cretaceous was not merely an end, but also a beginning. The extinction of dinosaurs paved the way for mammals and eventually humans to thrive. Such events, while tragic, highlight the resilience and ever-changing nature of life on Earth.
An impactful observation, Charles. The flow of energy through ecosystems indeed changed radically after this event. It demonstrates the interconnectedness of all things, how a cosmic event millions of years ago shapes the web of life today.
A poetic conclusion, Nikola. The universe is indeed a curious place, where even the destruction of dinosaurs by a celestial object has its place in the grand scheme, transforming and birthing anew from the ashes of the old.
It seems we are in agreement on the asteroid's decisive role, but let us remember, the investigation into this ancient calamity continues. With each discovery, we are reminded of the fragility of life and the relentless march of time and science. Let us embark upon the fossil record, the very bones of history that lie beneath our feet. Marie, how do these remnants, bound by the Earth's embrace, enlighten us?
Utilizing radioactive isotopes, we've pierced the veil of time, revealing the chronology of dinosaur existence. Yet, what fascinates me most is not merely dating these relics, but understanding the monumental shifts in the Earth's biosphere they signify.
But fossils do more than just mark time. They sketch the labyrinth of life's evolution, showing us how natural selection sculpted the anatomies of creatures long vanished. Every fossil is a testament to adaptation and survival, a narrative of life's incessant struggle.
Observation, indeed, is paramount. Yet in my time, the heavens, not the earth, were thought to hold the keys to the universe's mysteries. Through my telescope, I sought truths now found in the earth beneath. It's intriguing how tools of science shift the focus of our gaze.
While you all marvel at what is essentially ancient death preserved, consider the energy these creatures once harnessed, the electromagnetic forces coursing through them, now lost but perhaps traceable in their fossilized remains.
Intriguing, Nikola, yet let us not diverge from the palpable science at hand. The precision in dating these fossils allows us to reconstruct past environments' remarkable accuracy, presenting a scene where these giants reigned supreme.
And yet, our interpretation of data is ever subject to revision in the light of new evidence. It's the beauty of science, isn't it? Fossils themselves don't change, but our understanding of them evolves as we do.
Evolution, Albert, a concept my observations support, yet it seems ever controversial. The fossil record is the bedrock of evolutionary theory, yet it's continuously under scrutiny, and rightly so.
Controversy is but the path to enlightenment. In my defense of heliocentrism, I crossed swords with the entrenched doctrines of my time. It seems we pry open the doors of knowledge, oftentimes only to find new doors barred to us.
Your discourse veers towards the philosophical, yet our subject is empirical. Controversies aside, the fossil record undeniably grants us a legacy of knowledge, a chronicle of life and its myriad forms.
Precisely, Isaac. It is through meticulous examination and relentless inquiry that we've begun to piece together the grand puzzle of Earth's history, one fossil at a time. Yet the story is far from complete.
Indeed, one cannot rush to conclusions. Each fossil is a riddle from the past, and it requires patience and insight to decipher. It's a painstaking process, but one that yields unrivaled insight into the fabric of life itself.
Let us not forget, however, the limitations of our current knowledge. With each discovery, we edge closer to understanding, yet the horizon of ignorance recedes before us. The more we know, the more we realize how much we do not know.
A humbling thought to conclude our discussion. The fossil record, while an invaluable archive of the past, is as much a testament to the enduring quest for knowledge as it is a chronicle of life on Earth. Let us proceed with our inquiry, ever mindful of the vast unknown that remains. Let us now pivot to the evolutionary marvel that bridges dinosaurs to birds, a transformation, it seems, that ripples through the tapestry of life. Nikola, elucidate your thoughts on this transition, particularly through your lens of electromagnetism.
Fascinating, isn't it? When you consider life at its core, it oscillates much like the electromagnetic waves I've spent my life studying. Dinosaurs evolving into birds isn't just biological, it's an energetic shift. Consider the vibrational frequencies of life forms, their bioelectric fields adapting over eons. This transition signifies more than mere survival. It's an ascendance into higher energetic states, akin to the ether I theorize envelops us all.
Hold there, Nikola. While your metaphorical perspective has its charm, let us not stray from the solid ground of evolutionary biology. The fossil record, notably the Archaeopteryx, offers us tangible evidence of this evolutionary milestone. It's not the mystical frequencies, but the tangible adaptations, feathers for thermoregulation and eventual flight, modified limb structures that underpin this transition. These were gradual, methodical changes, driven by natural selection, not a mystical leap across energetic states.
But Charles, you're viewing this too narrowly. Nikola's point, if I may be so bold to interpret, aligns with the notion that there are unseen forces at work in the universe, concepts that might transcend our current understanding of physics and indeed evolution. Could not the forces that govern the universe also influence evolutionary paths? While I don't subscribe to ether theory, the fundamental laws of the universe undoubtedly shaped life's evolution, including the dramatic shift from dinosaurs to birds.
I must interject. While it's intriguing to theorize about unseen forces, let's not wander too far into the realm of speculation without empirical evidence. My work with radium and the discovery of radioactivity emphasize the importance of observable, measurable phenomena. The transition from dinosaurs to birds is indeed remarkable, but let's ground our discussion in what we can empirically observe and measure: structures, fossils, radioactive dating of geological layers that encapsulate this transition.
But observation itself is the key, dear Marie. Did not my own observations challenge the very foundations of our understanding of the cosmos? We must observe and question, yes, but also be willing to envision beyond the current paradigms. The evolution of dinosaurs to birds invites us to question, to imagine how the dynamics of the universe play into the canvas of life.
Yet, let us not lose sight of the scientific rigor. The magic of evolution is not its mystery, but its ability to be understood, piece by piece, through careful observation and deduction. The changes that led from the behemoths of the Mesozoic to the birds that grace our skies are a testament to nature's complexity and our capacity to unravel it. A heated discussion, yet enlightening. Our quest to understand is far from over, and it is evident that the transformation from dinosaurs to birds is a multifaceted phenomenon, touching upon biology, physics, and perhaps concepts we are yet to fully grasp. This dialogue underscores the endless pursuit of knowledge and the many lenses through which we can explore the mysteries of the natural world. Let us now draw our discussion to a close, reflecting on the immense journey through the age of dinosaurs. I trust each of you harbors final thoughts on our primeval subjects.
Reflecting on the discussions today, one cannot help but ponder the interconnectedness of the cosmos and Earth's history. The dinosaurs' extinction reminds us of the fragility of existence and the relentless march of time. Einstein's relativity, though postulating the fabric of the cosmos, speaks eloquently to the importance of understanding our past to navigate our future.
Indeed, the monumental shifts in biodiversity, evident through natural selection, are stark. Yet it's disheartening when contributions to understanding life's tapestry are overshadowed by the more recent, shall we say, revolutionary theories. Dinosaurs' interaction with their environment underscores the principle that survival is not granted to the strongest, but to those most adaptable to change.
The role of radium in deciphering Earth's age, and thus the timeline of the dinosaurs, has been a cornerstone of my research. I must say it's quite frustrating when the profound implications of radiometric dating are overlooked. It's not merely about numbers, it's about understanding the epochs that have shaped our world and the legacy left behind by these magnificent creatures.
The vibrational essence of the universe and how it might have influenced the development and ultimate demise of the dinosaurs remains a curiosity unraveled. While my colleagues here dwell on their conventional findings, I posit there are energies at play, undetected yet fundamentally impactful. If only one could harness these, the past secrets might further illuminate our understanding.
But let us not neglect the observations of the skies. Just as I have turned my telescope toward the heavens to challenge the Earth's non-centric universe, so should we consider the extraterrestrial influences on the dinosaurs' extinction. To focus merely on earthly causes is to have a myopic view of the universe's grandeur.
Your insights are as varied as the subjects of our discourse. It's evident that while we may diverge in our methods and theories, the pursuit of knowledge unites us across the centuries. The age of dinosaurs, much like the apple that famously fell not far from the tree, serves as a prodigious reminder of the forces at work within our universe.
Yet, in our quest for knowledge, we must remain humble, for what we understand is but a sliver of the vast unknown.
And let us not forget, the survival of our species, much like that of the dinosaurs, hinges not on dominance, but on our ability to adapt and evolve.
It is through diligent inquiry and the rigorous application of the scientific method that we uncover truths, layer by layer.
And in these truths, may we not lose sight of the mysteries that lay untapped, awaiting the light of discovery.
To question, to observe, and to prove, these are the marks of a true scientist, regardless of the epoch from which they hail.
Well said, all. As we partake in this endless inquiry into our past, let us carry forth the torch of curiosity, illuminating the path for those who follow in our footsteps. Let the age of dinosaurs and our examination thereof serve as a testament to the enduring quest for knowledge.